Hey everyone, it's Mr. Kaplan here, and I'm here to present the second lesson here for this section dealing with triangles. And today we will be talking about what are called similar triangles. And we're basically going to go over the calculations required in order for you to solve for the unknown sides and unknown angles of triangles which are deemed similar. Now, what similar triangles involves is that we're going to look at questions where we're going to have two triangles that are going to be um, different in orientation or size, but the sides themselves are actually proportional to each other here. And how we're going to do that is we're going to actually use a technique that I'm sure most of you were familiar with, especially in grade 9, and that's dealing with cross multiplication. So what we're going to do here is we're going to set up proportions because, like I said, with similar triangles, what's happening here is we have two triangles that may be in a different orientation or different size, but the sides themselves are proportional to each other. And basically, what a similar triangle is that since one triangle is smaller or bigger than the other, okay, there's going to be a ratio between them in terms of how much more bigger or smaller a certain triangle is. So once we do that, we're going to go through the math required to solve for that. And then we're also going to do a proof of how we can figure out if a triangle is indeed similar when you're using the ratios of their sides. So what we have here, and just to just make a note of some of the language that you're going to hear in this particular lesson. Whenever you have similar triangles, you're going to have this little squiggly symbol that indicates that two triangles are similar. And when two triangles are similar, there's going to be a statement that looks something like this. If triangle ABC is similar to triangle DEF, okay, there's certain properties that are going to apply for both the angles and the sides. So starting off with the angles, okay, notice that these two triangles, just by looking at them, the one on the left side is smaller than the one on the right side, okay, even though they are proportional to each other when it comes to their side lengths. Now, when the side lengths are proportional, so the angles are actually equal to each other. So for example, angle A and angle D will be equal, okay, angle B and angle E will be equal, and then angle C and angle F will be equal because these two triangles are again similar to each other, okay, so they will have equal angles. Now what you're going to see here is that when you're looking at the corresponding sides, what's going to give you an idea of what the corresponding sides are, okay, is based on the orientation of the triangle. Now another thing that is also that you can use to determine what sides are corresponding is the statement itself. So if it says if triangle ABC is proportional to triangle DEF, you're going to see that by looking at the order of letters, you can see which pairs are going to be similar to each other or corresponding to each other. And that's going to become very important once we actually start looking at which sides we're solving for. All right. So starting off with the first question here, it says determine or find the measure of angle C. So if you take a look at the left-hand side here, this is the angle that we're solving for, angle C. Okay, and basically you want to look on the other triangle, okay, the smaller triangle on the right, which angle is corresponding to that. So since these two triangles are similar to each other, okay, that means that they will have a corresponding angles based on basically on where the angles located here. So if you're looking at where angle C is and you're looking at the triangle on the right hand side, you should see that triangle C is equal to triangle left. So that means triangle C is going to be 31 degrees. Okay, so that's just based on the fact that these two triangles are similar, then that their corresponding angles are going to be exactly equal to each other. Now, when we're solving for the length of the sides over here, okay, now we have to do some math behind it. So it says here, find the length of line segment D to E. Now, what we want to do here, and what I want to introduce to you is how to set up proportions so you can see what numbers you have and what numbers you don't have. So it says here, since triangle ABC is similar to triangle DEF, we have to set up a proportion. Now you're going to see there, I'm going to show you two ways to do this. Okay, based on what you see in the diagram here, these two triangles are in the same orientation. Okay, they're both right side up, for the lack of a better description there. But another way you can do it here is you can take a look at the statement itself and just match up the pairs of letters in the order that you see them. So for example, if you look at the diagram here, if you take a look at side DE and AB, okay, these two sides here are similar. Okay, now another way you can look at it is if you look at the statement here for the when triangle ABC is similar to DEF, you notice that A and B in the first statement here, on the first part, okay, matches up with the E in the second part. All right, so that's just another way to do it, and that also comes in handy when you have triangles that are in different orientations, which we'll see later in this lesson. So I'm just going to go in clockwise order here. So A to B is similar to D to E. So when you look at B to C over here, that's going to be same thing as E to F on the smaller triangle. Now, what's also important here is preserving direction. So what I want you to see here is that for the last part, I'm going from C to A, and you notice I have an arrow on this blue arrow here, just to show you which direction we're going. So if you're looking at C to A on the left side, you're going to see that that corresponds to F to D on the smaller triangle. All right. Now you can also see when you're looking at the letters over here. Okay, so we have A to B, okay, which is the same thing as D to E. We have B to C, which is the same thing as E to F. Okay, and when you go back to the last letter here, you're going to look at C to A. It's the same thing as F to D. So you can use the statement itself to come up with this as well. So whatever you're comfortable with, that's the method that you use. Now that we have this here, this is now going to be the proportion that's going to help us solve the problem that we want to solve for. So the next thing we want to do here is to put the numbers in for the corresponding sides. So starting off with A to B and D to E, okay, we have the value for A to B, which is 12.1. And remember, D to E is the side that we want to solve for. All right. So if you're looking at B to C to E to F, I'm just going to rewrite that. And you notice there's no numbers for that. And we'll talk about what we're going to do with that after the next one. So when you're looking at for C to A and F to D, okay, notice what we have here will be 20.1 over 16.1. Now, what we want to do now is to pick two proportions such that we can actually use them to solve for the side DE that we want here. So since we're solving for side DDE, I'm just going to put a box around that. Now, in order for you to solve for an unknown side using proportions, you need to let it equal the proportion that has all of the numbers in it. And sure enough, if you take a look at this one on the last side, on the right side here, okay, that's what we're going to match it up with. So you're probably wondering, what in the world do we do with the one in the middle? Okay, we just basically wipe it away. So I'm just going to take these two proportions that I've put boxes around. I'm just going to bring them down. Okay, and I'm going to cross multiply. So when we cross multiply, what we're going to do here is we're going to multiply the 20.1 to the DDE, okay, and the 16.1 to the 12.1. So the next step over here, you can see we have 20.1 DE is equal to 194.81. Okay, in a similar fashion that you would do solving an equation, just for example, for single letters, what we have to do in our last step here is to divide both sides here by 20.1, because it's the number that's attached to the DE, which we want to solve for. Okay, and you can see that cancels out on the left side, and then DDE will give us a measurement here of 9.7. All right, so notice that we're going to actually look at any problem that's going to ask us to solve for the length of the sides. We're going to use proportions to solve for them. Okay, so you're always going to have 3 sets of fractions that you're going to use here, and then when you're solving for them, you can get rid of one of them and then let the two equal each other. All right, let's take a look at another question here. Now for this one over here, okay, we not only do we have 2 right triangles that happen to be different sizes, but notice they're in different orientation. Now, what's important for this one here, when you're labeling the sides, is that using this over here, okay, the statement itself is going to be coming in very handy, okay, for us to come up with the proportion statement here. So what we have here is triangle FGJ is similar to IHJ. So anytime you're getting a similarity statement, okay, the order of the letters, the corresponding sides to it are going to be in the same order as the other one. So the way we're going to do that is exactly that way, and we're also going to make a note of it in the diagram over here. So our first proportion that we're going to have here is F to G. Now notice that in the very top here, F to G is the first 2 letters. So F to G is going to be similar to I to H. Now, I want you to see in the diagram that with the red arrows here, okay, what I'm doing here, even though the arrows are pointing in opposite direction, okay, in terms of the tips of the arrows, okay, what we're doing here is preserving the orientation. Okay, and the reason for that's because when you're preserving the orientation, okay, it'll give you a rough idea where the sides are in relation to the triangles here. Okay, so that is our first proportion. Now the next one here, I'm going to go in this order. We have G to J. Okay, and we look at G to J, that's going to be corresponding to H to J. Okay, now I'm using the letters that are in the statement here and then making the note on the diagram as well. So even though that these arrows that were the heads are pointing each other, they are preserving the direction there. All right, so there's a second one. And last but not least here, we have J to F, okay, which is corresponding to uh, J to I. All right, and that's our last one there. Okay, next thing we're going to put in the numbers. So you're going to see when we put the numbers in here, starting off with F to G over I to H, okay, that's going to give us F to G over 4.3. And as you can see, F to G is F to G is actually going to be the set of letters we're going to be solving for. Okay, and then G to J to A over H to J has no numbers, so we're just going to write it as is. And last but not least, we have 18.9 over 6.3. Now, what we want to do here is to solve here. So since we're solving for F to G, let's put a box around that and a box around the fraction that has all the numbers, which in this case here is the 18.9 over 6.3. So once you've identified which two fractions you're going to use, now you can solve for them using cross multiplication. All right, so from there, now you can cross multiply. Now remember, when you multiply a number to a letter or a set of letters, the number just goes in front of it like so. And last but not least here, we just need to solve for F to G here over here. So we're going to divide both sides here by 6.3. And this is going to give us a value of F to G to be 12.9. Okay. So you can see here, in this case here, what we had to, the easiest way to do this, if you're not too sure which sides are corresponding, always take a look at the statement itself and then just go in the order of the letters. Okay. And when you go in the order of the letters, okay, you will come up with the three fractions when you're setting up the proportion. Then from there, put in the numbers according to the corresponding sides. And then from there, solve for the quantity that it's asking you to solve for. All right, so let's take a look at another example here. Now, for this one over here, what we have here is a triangle within a triangle. Okay, so it says here in this diagram, it tells us that DE is parallel to AC. So what I want you to see here is that when you're looking at these two triangles over here, we have two triangles which I've outlined there in red for the first part. So what I have here is triangle BDE. Okay, just keep in mind the direction I'm going in. So since triangle BDE is similar to BAC, which is located with the bigger triangle here, what we can do here is to use the proportions to solve for this unknown length DE. Okay. Now be careful when you're doing this one here, because you notice we have a triangle within a triangle. So, and when in doubt, use the similarity statement in order for you to draw the fractions to make up the proportion. All right. So if you look at B to D, starting off with that, okay, you're going to see that when you're looking at B to D, okay, the corresponding side to B to D will be B to A. Now you're going to see for B to A, that's this entire length here. So I'm just going to fill in a gap over here. So the entire length of B to A, okay, is going to be the result of adding 30 and 15 together, which gives me 45. Okay, so I just want to put all the numbers in before we put in the proportions. All right, start putting in the proportions. So we have B to D and B to A. Okay, next one here in that order. So we're going to look at D to E and A to C. Okay, so we have D to E and A to C. And last but not least here, we're going to go E to B, okay, and C to B, okay, because those are going in that same direction there. And the next thing we want to do here is to put in the numbers. Now again, be careful with putting in the numbers because you're going to see something with the first one. If you take a look at B to D over here, okay, the B to D gives us the 30. If you're looking at B to A here, you're looking at this entire distance, and that's why we simplified it first by taking the 30 and the 15, add it together to give me 45. So BD over B to A will give me 30 over 45 there. Okay, next one, we have D to E over 30. And this last one doesn't have any numbers, so we're just going to rewrite it the way it is. Now in this question here, since we're solving for a line segment to D to E, put a box around that first. Okay, and remember you always have to let it equal the fraction that has all the numbers in it. So in this case here, I'm going to take the 30 and 45. Okay, E to B, we're going to say bye-bye to, and bring these down and cross multiply. So from here, we're going to multiply the 45 to the D to E, the 30 to this 30, and that'll give me 45 D to E equals 900. And last but not least, Okay, we're going to divide both sides here by 45 to cancel the 45s on the left side, and that's going to give us a value here of 20 centimeters. Okay, so the length of line segment DDE will be 20 centimeters. All right. So keep in mind that for this one, just be careful when you're putting in the numbers, because for especially when you have a question similar to this, because for the full side length here, in this case, it was line segment B to A. Okay, we had to add the two numbers together because that was the total length for B to A there. All right, the last thing we want to do, we just want to do a proof that two triangles are indeed similar. So it says here, show that triangle MNP, okay, is similar to HJK. Okay, so what we're going to do here, we're going to match up the corresponding sides first. Okay, starting off with M to N. So you can see M to N is similar to H to J. Okay, and we have N to P, which is similar to J to K. And last but not least, we have P to M, okay, which is similar to K to M. Now, what we want to do in the next part is put in the numbers and see what we come up with when it comes to the values over here. So starting off with the first one, we have 4 over 10 here. Okay, and when we divide those two numbers together, that gives us 0.4. Okay, so for this one here, we're going to use our decimal answers because it's going to help us see if these triangles are similar or not. Okay, next one we have here, we have 7 over 17.5. We're going to divide these two numbers into each other, and what do you know? We have 0.4 as well. Okay, so let's try the next one here. So we have 6 divided by 15, and that gives me 0.4. And you notice since all of these here are the same, okay, this tells us here that triangle MNP and HJK are similar to each other. Okay, so that's only going to hold true if all of the ratios are the same for all three sides. All right, so that wraps up my lesson on similar triangles. So for the next lesson, we're going to wrap up similar triangles, and we're just going to look at some word problems that deal with similar triangles. All right, until then, I'll see you in the next lesson.